Alright class, in this video we learn about the inverse tangent function, section 6.4 in your textbook. So we're starting at the top of page 5 of your lecture handout. So just like the sine function, the domain of the tangent function has to be restricted in order to define an inverse tangent function. Back in section 5.3 we learned about the graph of the tangent function. And so here the graph of the tangent function is again. And the graph of the tangent function consists of all these red curves. And so if you remember that the domain of the tangent function is all real numbers except for odd multiples of pi over 2, where we have these vertical asymptotes occur at odd multiples of pi over 2. So you can see that no matter where I draw the horizontal line, it's going to intersect several of these red curves, right, that make up the graph of the tangent function. So the tangent function in here is not a one-to-one function. But mathematicians way back when wanted an inverse tangent function. So what they did was they kept this part of the graph of the tangent function right here from minus pi over 2 to plus pi over 2, and then they threw everything else away. And so this is what we have right here in blue, the part of the tangent function from minus pi over 2 to plus pi over 2. And you can see that after throwing everything else away, with just this part of the graph, right, it passes the horizontal line test. And so by restricting the domain to minus pi over 2 to plus pi over 2 radians, which is the same as minus 90 degrees to plus 90 degrees, they created a one-to-one function. And so it has an inverse. So down below here is the graph of the inverse tangent function. Excuse me. And so on the horizontal axis, right, you can see the domain of the inverse tangent function is all real numbers, and the range of the inverse tangent function, which is the corresponding y values, goes from minus pi over 2 radians to plus pi over 2 radians, or minus 90 degrees to plus 90 degrees. So this is the notation for the inverse tangent function. Remember, the -1 in the superscript does not mean reciprocal. It's just fancy mathematical notation to represent an inverse function. So this is the inverse tangent of the number x. So y is an angle, and x is the number you put in to the inverse tangent function. So this point right here, x is equal to 1, and y is equal to pi over 4 radians. So the inverse tangent of the number 1 is equal to the angle pi over 4 radians. So on the next page, we summarize the domain and range of the inverse tangent function. Its domain is all real numbers. You can put in any real number in for x here. And output angles y go from minus 90 to 90 degrees, or minus pi over 2 radians to plus pi over 2 radians. So again, range is from minus 90 to 90 degrees. So similar to the inverse sine function, we're using the right half of the unit circle in defining the inverse tangent function. Minus 90 degrees is down here, right? It's the angle starts at the positive x-axis and you go in a clockwise direction, and the terminal side of minus 90 degrees is the same as that for plus 270. So the output angles to the inverse tangent function start here at minus 90 degrees and going counterclockwise, go to 0 degrees, continuing counterclockwise, go to plus 90 degrees. So if it's true that the angle y is equal to the inverse tangent of the number x, then it's also true that the tangent of the angle y is equal to the number x. So let's table down here kind of summarizes the inverse tangent function, the numbers that go into the inverse tangent, and the angles that come out. So over here, right, we have the tangent function of the angle theta. So minus 60 degrees is the same as minus pi over 3 radians. And we know the tangent of minus 60 degrees and the tangent of minus pi over 3 radians are both equal to minus the square root of 3. So it's also true then that the inverse tangent of minus square root of 3 is equal to the angle minus pi over 3 radians, or minus 60 degrees. So let's do another. So here we have the angle 30 degrees, which is the same as pi over 6 radians. And we know that the tangent of 30 degrees and the tangent of pi over 6 radians are both equal to 1 over the square root of 3, which is the same as square root of 3 over 3. And so it's true, it has to be true then that the inverse tangent of 1 over square root of 3, which is the same as inverse tangent of square root of 3 over 3, is equal to the angle pi over 6 radians, which is the same as 30 degrees. So let's look at a couple examples, exercises on the next page. You're asked to find the exact value of each expression. What's the inverse tangent of square root of 3 equal to? Well, from the table on the previous page, right, tangent of 60 degrees is equal to square root of 3, and the tangent of pi over 3 radians is also equal to square root of 3. So consequently, the inverse tangent of square root of 3 is equal to 60 degrees, which is the same as pi over 3 radians. In the next example, you're asked to find the inverse tangent of the number 0. Well, from the table on the previous page, the tangent of 0 degrees is equal to 0, and the tangent of 0 radians is equal to 0. So consequently, the inverse tangent of the number 0 is equal to 0 degrees, which is the same as 0 radians.